welcome to another episode of Streamlit Live. I'm your host, Tony Kipkemboy, and I work on developer relations for Streamlit at Snowflake. Today, we are diving into the fascinating world of RAG, or Retrieval-augmented generation, with a special focus on advanced concepts like the many ways you can tune text-based RAG, including pre-processing, chunking strategies, embedding models, and metadata. I am thrilled to be joined by Eugen Tang, who is a senior developer advocate at Zillis, who brings a wealth of knowledge from software development, AI, and vector databases.
Hey Tony.
All right,
Really,
Eugen, welcome to Stream It Live. Glad to have you on today.
yeah, I'm glad to be here. I'm really excited to talk about RAG with you guys. This has been such a huge thing that's come up in 2023, and I expect it's only going to get bigger this year.
Yeah, absolutely. You're right. A lot of things are moving just within the AI space, so it's exciting to have you on to talk about some of the more important concepts here as well. So, usually, before we jump into the main topic of the day, I just want to kind of take a moment to talk about you for a second, and kind of jumping into your background real quick. You graduated from University of North Carolina at Chapel Hill with a bachelor's in computer science and a minor in neuroscience and statistics. So that's very interesting. I think you need to tell us what OB rubbed because you kind of foresaw the future. There's a good intersection between computer science, neuroscience, and statistics, especially in AI. So we'll get into that. But since you've graduated, you've achieved a lot just within your career and your in your life so far. So you worked at Amazon as a software engineer, and you've also been an entrepreneur. You're a blogger, and currently, on top of that, working at Zillis as a senior developer advocate. So that's just a quick snippet. I'm sure it doesn't do justice to maybe some of the stuff that you want to share. And maybe, I want to give you a moment to first of all tell us about the neuroscience, the major thing. And then on top of that, tell us a bit about just your background or some of the things that you think I've missed that are important.
Sure. So I'll kind of cover like why did I do statistics and neuroscience. I started doing software engineering when I was 16. I started working at IBM,
Oh.
and I was there for about 3 years before I went to college, and I basically had my career path carved out, for my major at least carved out for me. Basically software engineering and computer science, right?
Yes.
So I went and did computer science, and I did pretty well. And I did all right in my first few classes. I was, kind of slacking off for the first few years of college. But I ran into this opportunity to do research at a neuroimaging lab run by Dr. Martin Steiner. And so I took that opportunity and I did research in his lab, and I was like, whoa, like this is really cool. I really like what I was doing was doing automatic segmentation of brain imaging.
Oh.
And I was like, whoa, this is like some cool shit. And so um, naturally that kind of led me to be like, oh, you know what? I kind of want to study neuroscience a little bit. And because I had that background and because I had that interest, I decided I was going to take some neuroscience classes. And statistics was so I come from a math background, and if you talk to people who are math majors, they'll tell you that statistics is not real math. It's easy,
Yeah.
but that's not true. And
Yeah.
but it is naturally a part of machine learning. And I took my first machine learning class for CS, and I got like a C in my first machine learning class, and I was like, man, this is hard.
Yeah.
But there's also the opportunity to take the theoretical introduction to machine learning via statistics.
Yeah.
And so I took that class as well. And that one actually made much more sense to me than the computer science one. And so that class I almost aced, and I was like, I better get something in stats because clearly I have a penchant for this kind of thing.
Yeah.
And it just so happens that it's also a very important piece of machine learning. And because I was doing neuroimaging and I was, in this kind of space, I just kind of I naturally gravitated to do this. And then afterwards, when I was at Amazon, I actually was assigned to a random team at Amazon initially, and I was very lucky with this. So I reached out to my hiring, not the hiring guy, the guy who I was assigned to his team, for him to be my manager. And I was like, hey, like, here's a little bit of background about me, blah blah blah. And if there's opportunities to work in AI here, I would really like to do that. And so he was like, well, let me transfer you to our sister team, which works on the AutoML program. And so I got to work on AutoML at Amazon, And that was super interesting to see, and that was really cool to do. And then I spent some time at Amazon, and I was like, hey, so, at big tech companies like the size of Amazon and Google and Microsoft, you got to do these like promo docs. You got to write your own promo docs. And when you do, you have to talk about like, the projects you do and how much money you make the company.
Yeah.
And basically I was like, oh, well, I'm making millions of dollars for Amazon. Is it possible that I could do something like this for myself? And so that's how I got into startups. And I got into startups, and my first startup was a total disaster. I basically threw my like life savings at it, never figured out how to monetize it, and I was like, "Oh, that was a bad idea." But I kind of consider it my MBA of the streets. The real,
Yeah.
yeah. You get to do an MBA, like lose some money, but same cost.
Yeah. You got a crash course.
I got a crash course. Yes, I got a crash course. And so from there, I did some contract writing. I started another company doing natural language processing as an API. And that one, I actually managed to get some revenue. I managed to sell that company. And then that one I was running from 2021 until about January of 2023. In November of 2022, ChatGPT came out, and I kind of looked at this and I was like, I don't have the skills or the resources to compete with this.
Yes.
So I'm going to go do something else. And I happened to interview with a bunch of companies at the time. And the most interesting company at that time for me was Zillis, because vector databases are actually extremely related to large language, to natural language processing
Yep.
and large language models. Because what they do is they do this thing called semantic search. And one of the challenges that I had when I was doing my NLP API was the semantic stuff. One of the things that people wanted was this abstract summarization, but abstractive
Mhm.
summarization is actually incredibly difficult to do. And so what I was able to provide at the time was only extractive summarization, which is where you just take some of the sentences and just, put them in there in a way that makes sense.
Yeah.
But I saw that, ChatGPT has this ability to do abstractive summarization as well as many other things. And one of the important pieces of using these LLMs with your data is that you need basically a vector database to hold your data so that you can work with that data. And so I was like, well, this is the most interesting company that I could be at. This is the most interesting field I can be in. And so, so I started at Zillis. And since then, I've just been building a bunch of RAG apps, a bunch of AI agents, and that kind of stuff over the last year.
Awesome. Awesome. Yeah, it's very interesting to see your journey so far. You kind of from academia to actually experimenting out there in the field, building your own startup. Like you said, a crash course on MBA, that's probably the best way to do it. And and now, to what you're working at right now, there's a lot of correlation there with what, your journey and where you are at the moment. And I just have to point out, you do this, you have this short, I can call them shorts, right? Like these short videos that you usually do explaining
Yeah,
a concept, you break it down. I really enjoy those. They're really easy to digest. And yeah, I always find those really nice to watch.
thank you.
Yeah, absolutely. And now, shifting gears a bit to Zillis and Milvus, uh, just before we get to the demo, because we have a demo for everybody that's watching. So Milvus is an open source software, and it was developed by the same team, as I understand, that or the team kind of currently behind Zillis, which is very interesting. And also, I guess the difference between the two, as I'm understanding, and I'm going to give you a moment here to explain it to us. Zillis is more of like the managed cloud service that sits on top of Milvus, if I'm not wrong. And then also, with that said, I want to give you a moment to at least explain to us a bit what's the difference between the two, and so for people that are not aware of it.
Yeah. So Milvus is our open source vector database, and it was something that was started in like 2017,
Yeah.
and Milvus one. So Milvus is currently on its second version. Milvus one was there was some good adoption for it, and it was donated to the Linux Foundation. And as like the team was talking to customers
Yeah.
in like 2020, 2021, one of the things that they found as a pattern between all of these customers was, okay, we really want to build something that needs to be able to support millions, tens of millions, hundreds of millions, billions of vectors. And in fact, one customer came to us and was like, we want to support 5 trillion vectors. And, at the time, the team was based like, oh,
That's a lot.
well, we need to redesign. Yeah, it's a lot. Like we need
Yeah.
to redesign the whole system. And
Yeah.
so that's how Milvus 2 was kind of created, basically to basically what we did was we moved Milvus from this single instance, kind of like, you put it on one machine, it runs there as a server like that, to this whole distributed system. And
Yeah.
so now Milvus is this kind of distributed vector database, and really it's a compute engine. And what it does is it kind of, takes care of a lot of the scaling problems that you would have. So it is focused on being able to do this horizontal scale. And there's a bunch of there's like a separation of concerns in terms of vector search. Or in terms of search in general, really,
Yeah.
there are three concerns. One is querying, which is like, how do I, which is actually getting your data.
Yes.
One is data, which is like, how do I move the data around? Where do I put it? When do I seal my segments? And then there's indexing. And indexing is basically like, how do I, create the way I'm going to search my data? And so there's this kind of like natural scalability that gets built into Milvus. And Zillis actually, Zillis launched the cloud product just last year, just last April.
Oh.
And what Zillis is you can think of Zillis as Milvus plus some sort of like optimizations in that kind of like hardware middleware kind of like interaction layer.
Okay.
And so we have a bunch of benchmarks out about this. And you can see that Zillis, you can basically tune Zillis to be a little bit faster, because Milvus is very, very customizable, and there's a lot of tuning that goes into it. And unless you have like strong expertise in distributed systems and vector search, it's kind of tough to optimize that for your use case.
Okay, awesome. Yeah, that's really good to be able to get that distinction between the two. And as we go along, we will definitely unpack some of those things that you mentioned there as well. And so, just a final question here before we get to actual demo. Maybe somebody's been listening so far and is, they're still stuck at RAG. Like what is RAG?
That's right.
What are these folks talking about? So I just want you to take a moment here to explain what RAG is for maybe somebody that's new to this.
Yeah, so it's the thing that you wash your dishes. No, I'm kidding. So RAG is retrieval-augmented generation, and what it is it's when you take your data and you vectorize it with an embedding model. You embed your data into a vector, and then you put that vector into a vector database. And then when you want to interact with your data, when you want to chat with your data, let's say, you would put an LLM on top, and you would interface with the LLM.
Yep.
And before the LLM returns a response to you, what it would do is it would take your questions, and it would kind of structure your questions in a way to look into the vector database to find things that are semantically similar, and it would bubble that up to the surface. And then it would basically refeed that back into the LLM and say, here's your context for answering this question. And then now the LLM has the context of your data, so it understands like how to answer your question. And I'll give you kind of like an example of this that I talked about recently that kind of makes sense. So I was working with Voxel 51 on creating this kind of embedding, showing like embeddings and how they work and things like that.
Yeah.
And there's this data set called CIFAR 10. And so in this data set, you've got a bunch of different ones, but two of the things you have are horses and automobiles. And so one of the things that we looked at was, if you look up Ferrari, which its image is a horse, you'll get automobiles back. If you look up pony, that's a horse, you'll get horses back. But if you look up Mustang, you get both horses and cars back. And so if you want just cars back, then you want to have that in your vector database. You want to have context there of just the cars, right? So that's like an example of what that context really means in RAG. And that's basically what RAG is.
Thank you. Yeah, I think that's very clear. And if somebody was kind of still lost in the weeds, I think hopefully this kind of gives them the base first before we get to the demo, which kind of we will dig more into this. And so with that said, this is the time for the demo. So I'll give you the screen here to be able to share your demo with us.
Yes, let me pull this up. Oh, that's not the right screen. Here we go.
All right.
Yes, you can. Okay. So my demo here today is going to be about, we're going to use Mixtral from Octo AI, served by Octo AI. And we're going to use Milvus, which I'm going to run with Docker Compose. And I should share that link. So let me get that link as well. So We're going to run Milvus with Docker Compose, which means is we're going to spin up these 3 Docker containers. One is etcd, which keeps track of state. One is min.io, which keeps track of the data. That's your permanent storage later. And then one is Milvus, which is the compute engine that does all of the vector search. And then I have an Octo AI key. So, I'm basically going to be just getting Mixtral, which is an open source model. And I'm going to be using Mixtral from Octo AI. So, I'm also using LangChain, which is a very, very popular LLM orchestration framework. So let's hope this works.
Yes. Demo. The
All
demo
right.
got to be with you.
So the first thing we're doing was we're just doing some imports here. Basically, I'm just going to get the LLM chain, which is LangChain's way of putting together pieces of the LLM application. I'm going to get the prompt template, which is LangChain's way of giving you a way to prompt the LLM. And then I'm going to get Octo AI endpoint, which is LangChain's way of interacting with Octo AI.
Okay.
And that's all I'm doing in that tab. And now here what I'm going to do is I'm going to load up my Octo AI API token. And basically all I need for that is the .env and the OS. So, .env is one of the ways you can manage your environment variables, and OS is just, it's an operating system basically.
Yeah.
And then in the next block, what I'm going to do is I'm going to create a template here that basically tells the LLM what to expect. And so in this case, I say, below is an instruction that describes the task, write a response that appropriately completes the request. Here's your instruction, and it's the question, and then basically tells it to do a response. And then I turn that into a prompt template, which is the LangChain's way of interacting with prompts.
Okay.
Now what I do in the next block here is, I'm going to zoom in a little bit. It might be helpful. So what I do in the next block here is I get the Octo AI endpoint. I tell it what model we're going to use. In this case, it's Mixtral 8x7b, which is their mixture of experts model. And I just say, hey, we're just maximum of 128 tokens. Don't be too creative. That's the temperature here. And then basically telling it like, hey, you're a helpful assistant. Keep your responses limited to 1 short paragraph. Okay, that was quick. Nice. Okay. In this case, what we're just going to do is we're just going to test that the LLM is working. This is not, this is no context yet. This is just the LLM.
Yeah.
And hopefully this should give us a response quickly. Okay, so who was Leonardo da Vinci? Leonardo da Vinci, 1452 to 1519, was an Italian polymath who is often regarded as one of the greatest painters in history. He's also celebrated for his blah, 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 blah. Okay, so clearly, Mixtral has been trained on a lot of data, and it knows who Leonardo da Vinci is. And it gives this nice, human-readable response.
Yeah. And
now what we're going to do is we're going to get Octo AI's embeddings and Milvus from LangChain. So embeddings are the embeddings models control, or let's say, map out what the context, how the different pieces of text might be related. So it maps out your context space. And in this case, we're going to use the one from Octo AI, and the default embedding from Octo AI is, I believe it's GTE large, which is a popular embedding model that ranks pretty highly on Hugging Face's leaderboards. Now I'm just going to do a couple more imports here. Basically, I'm going to get the documents so that I can read in this data. The data that I have for this example is a bunch of documents about a bunch of different cities. So, Boston, Seattle, and some other places. And then the character text splitter is a way that we split text in LangChain. Okay, and then I'm just going to read in this file list. I'm going to make sure that these file texts know what they are. And then I'm going to initialize an empty list for our files. And then what I'm doing here is I'm basically saying like, okay, for each of the files that we have in this list of files, we're going to open it, we're going to read it, and then we're going to split that up and make sure that there's going to be some chunk size and chunk overlap. So at the beginning, we talked about how chunking was one of the important pieces of RAG. And what chunking is it defines the size of the text that you're going to be working with and you're going to be vectorizing. And chunk size is typically kind of like played around with in powers of 2, but really, it's up to you to depend, and it depends on what your document kind of looks like to kind of play around with this. Since we're just working with classic Wikipedia documents, 512 is like maybe like, it's like maybe like 100 words, so like a paragraph or so.
Okay.
And then 64 is the overlap between chunks. And so you'll typically have like some overlap. This is maybe like one sentence or so.
Yeah.
You'll have some overlap between your chunks. And the reason why you want to do that is just so you can have, you can make sure, or not entirely make sure, but that you can encourage more contextually sound chunks. And then we just split this text. So this is a way that we split the text. So we're basically like, hey, like, you know, if there's a period, if there's like something that indicates the end of a line or sentence, just split on that, you know, close enough. And then for all of these, what we're going to do is we're basically just going to put the metadata in. So the metadata that we're going to keep track of in this case is the doc title, which is the title of where the data is coming from. And in this case, is going to be a bunch of cities. And then the chunk number, which is like which chunk of the Wikipedia doc this was. So this might take a second to do. Okay, so there we go. And you see that, you know, not all the chunks are 512, but it tries to keep it to about that size. What did I just do? Okay. Before we can use Milvus, what we need to do is we need to actually spin up Milvus. And so you can see that I have copied this Docker Compose file, and that's where you can get this Docker Compose file from the link that I've put in the chat. And so this will be Docker Compose up-d, and okay, I've run into a Docker issue here. So what I'm going to do is I'm going to clean up my Docker repo and then try again. There we go. Okay. So now, you know, we've got Milvus running, and so we should be able to connect to it. And so here, what I'm going to do is I'm basically using Milvus, which is imported from Llama Index. And I'm saying, like, I want you to create this collection from this documents. And here, you know, the file text, which we just created up here, as well as the embeddings, which we created with the, sorry, these are actually called from the embedding model. It uses a function to do this. And then how to connect to it. So Milvus is typically run on port 19530.
Okay.
And this is, you know, it's on localhost, and we can name the collection. And so I'm just going to call this cities. And now what we'll do is, or what the program will do is, it will basically go through all of that list of documents, all those chunks of data, and they'll start embedding those with the GT large model and storing that embedding into Milvus. And Milvus is running, you know, at this host and port. And there's 3 different containers that are running on Milvus. So you can see there's MinIO, which is the permanent storage layer. There's etcd, which is the what keeps track of the state. And Milvus uses stateless nodes, like I was talking about earlier, the querying, the data, and the indexing nodes. They're all stateless nodes. And the etcd is what keeps track of that state so that, you know, Milvus knows what's going on. And then, of course, there's Milvus standalone, which is the engine itself. And so this should only take, like, I don't know, like a couple minutes. It shouldn't be that long. Oh, okay. So it finished in under a minute. That's great. And let's just check what this looks like so we know what's in these things. So we can see this is a document object, which is a LangChain native. And it's basically saying, like, okay, this is Chicago. Here's this information about Chicago, blah, blah, blah. Most populous city in the state of Illinois, 3rd most populous in the US after New York and Los Angeles, blah, 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 blah. Okay. So now what we need to do is we need to make this vector store into a retriever. So this allows LangChain to retrieve data from this, and it's no longer just an independent vector store.
Yep.
And then we're going to give it some sort of template, basically say, hey, here's the question, here's the context, and here's the context, answer the question. And this is how the prompt template kind of works. You'll notice that we did something earlier, and this is slightly different, right? Now we're giving it the context as well. And now we're going to create this LangChain chain of things. So basically, we're going to get these runnable pass-through is a way to just, you know, pass through data, and string output parser is a way to output or parse the output as a string. And then we're going to create this chain here. And so in this chain, we're going to basically create this way to give a context and a question, which is then pass the prompt, which we created up here, which is then pass the LLM, which will then be passed to the string output parser, which will parse the output of the LLM into a string. And that should be quick. And then I'm just going to ask how big is the city of Seattle, and it should give me, Seattle is the most populous city in both the state of Washington and the Pacific Northwest region of North America, with a 2022 population of roughly 750,000. The Seattle metropolitan area has a population of 4 million. Just for fun, I know you're based in New York, right?
I actually am in Maryland.
Okay, well, I
I
don't
used
have
to be.
anything about Maryland, so
Yeah.
we're gonna ask about NYC. Okay,
Close enough.
you're on the East Coast.
Yes,
Oh, I
yes.
don't have anything about NYC in here, do I?
Yeah.
I don't have anything about NYC. Okay, let's ask about Boston. Okay, whoops.
Yeah.
But see, it knew that this enclosed information didn't have information about New York.
Yes.
See, it knows about Boston, but it gives me a slightly different answer. It says city of Boston is this big. Okay,
Right.
so let's have some fun with this. What we're going to do now is we're going to use one of the experts included in Mixtral. And the expert we're going to use is the language expert. So Mixtral has this ability to give you this language, multilingual kind of capability. And so what we're going to do here is we're going to tell it, you're a helpful assistant who responds in French and not in English. And answer the question in French based on the following context.
All right.
It's going to be a French prompt with a French template. All right, let's hope this works. And so now I'm going to use the French chain to ask how big is the city of Seattle? And it's going to come up with a response. And we're going to pretty print this out so we can read this in French. La ville de Seattle. Okay, I'm just not going to butcher this.
Yeah.
But anyway, you can see, 4 million, I don't know what this means. The population size is here. It's big in Washington, 4 million inhabitants, blah, blah, blah. So you can see that, when we use this LLM, we can give it different instructions, and we can give it the same set of data via RAG, embedded in Milvus, and we can ask it in different questions, and it will give us a different response. So yeah, that's pretty much what the demo looks like.
Awesome. This is awesome. And one thing that I'm looking at right now on that translation there from French, it looks like it has a lot of words compared to English response, but maybe it just takes a lot of words to explain the same concepts in different languages.
It might be. Let's see. I think this is saying like the city of Seattle is a big, grand sounds like big.
Yeah.
And population of this in 2022, the city is the biggest, has the most people in Washington and in the region of the Pacific Northwest and of America. Wow. Okay. So Pacific Northwest of America is right here, I think.
Okay.
And then the larger metropolitan area of Seattle composes 4 million inhabitants. Words I don't know.
Yes.
More words I don't know. And it seemed like it gave a longer response, because I think this is pretty much where the English response cut off.
Yes.
And the reason for that is probably because, we're giving it this kind of like temperature, a little bit higher temperature in the French response than the English one. And temperature is basically how creative the LLM will be.
You want it to
so
be,
that's probably why it's a little different.
Okay. Pretty cool. I'm sure somebody in the listeners in the audience, they probably will point out, hey, that's not what it says in French. But yeah, that's cool. Yeah, this is a really cool demo to be able to see the power of Milvus, and also how I guess you can use RAG to kind of supplement the recent knowledge that most of the LLMs don't have. So this is really cool. Yeah, so we'll switch over to continue, maybe talk a bit more about some of the concepts you mentioned. Some things stood out for me there that I want to kind of dig a little deeper on. The first one is kind of, we'll start from the top. So from like thinking about it as a pipeline, starting from the data part. Data pre-processing is something that's very important in this RAG process. So we want you to give us like a kind of maybe a brief explanation with some examples of maybe what are the common steps for pre-processing this data before you load it into a RAG pipeline.
Yeah. So the basic steps for getting, or let's say probably the more advanced steps, but the basic step is you take your text, you embed it, and you put it into a vector database. And then when you realize that that's probably not going to work for everything, what you start doing is you chunk up your data so that you have like smaller chunks, which means that you're going to have more pieces of data to put in, but it also means you're going to have a more refined granularity for your context. And there's a bunch of different chunking examples. For example, how big should your chunk size be?
Yeah.
Well, that's going to depend on what your data looks like. So if your data is in a bunch of paragraphs, like 512, 1024, these are reasonable paragraph sizes. Once you figure out how big your chunk sizes are going to be, you got to think about things like, do I need chunk overlap? How much does it need to overlap? And then maybe even like, should I split on special characters or things like that? So for example, if you have like just like a chat log, like you're texting your friends, you got a bunch of texts, you want to make a text bot that texts like you, like you probably want to look at special characters, like like the ending of a message or things like that, the beginning of a message, things like that, and you want to split based on that. And you probably don't need any overlap in those cases because you're kind of just like trying to get it to sound like you, which actually might be might be good to do RAG, but also might be good for fine tuning. So there's a couple different methods to kind of tune your LLMs to do things for you. But once you have that, your data chunked and embedded, and you put it into a vector database, as you put it into like a vector database like Milvus, one of the things you got to think about is what kind of metadata do I need to store?
Yeah.
And so you'll see in this example, I just stored the name and like the number of the chunk. But oftentimes you'll also want things like the author, the publication date, maybe the title of the section, or a bunch of other things like that you might want to have in your data. And so these are pretty much the three important pieces of the data pre-processing. So one is chunking, the number two is embedding, like the embedding model that you use. In this example, we just used GTE large, which is just a popular model. But if you're working in like a specific industry, like maybe like healthcare, you're probably going to want a model that's trained on healthcare data.
Yes.
And then the last one is just the deciding on what kind of metadata you want. So those are the three pieces of, let's say, data pre-processing that are very important for RAG.
Awesome. And I guess zooming in a bit on metadata, which is really important, and I think a lot of people miss that step. You would say maybe from your experience as well. I think a lot of people miss that step, which kind of does affect a bit the output that they get from the models from the RAG application. So for metadata specifically, is more better in this case.
It's not always like more is better. The way that the way that you can use your metadata is basically Milvus has this feature that we call hybrid search, and hybrid search is a kind of what is the word for it? A contentious term in the industry, because many people say hybrid search and they have a different definition of hybrid search. But my definition of hybrid search, and by the way, the definition of hybrid search, the right definition of hybrid search, is when you search a vector and you do some sort of metadata filtering on it. And basically what you can do is you can write an expression, kind of like a regular expression, but not exactly, in Milvus, and you can pass that expression in. And what you can do with that expression is you can filter on the metadata. And so let's say you have a bunch of different articles, and some of these articles are written by, the author is Tony Kipkemboy, and the other one is Yujian Tang. And then, there's like a bunch of other different authors, like, F. Scott Fitzgerald or whatever, or Caroline Liu, these people, right? So what you can do is you can say like, okay, I only want responses. I only want these chunks that are written by Tony. And then it'll say like, okay, author name equals Tony Kipkemboy. And then what happens in Milvus is, so this is going to be, it's going to be a linear runtime initially. So it's going to go through all the data, and it's going to create a bit mask, and then it's going to filter vector search on that bit mask. So it's actually more effective to pre-filter this and do that linear runtime, and then go in to do the vector search, because vector compute is a much more expensive operation than just checking for an equal sign, basically.
Yeah, awesome. Yeah, I think that makes a lot more sense that way, and it's also awesome to hear about how Milvus kind of handles that side of things. Another thing that maybe we want to talk a little bit about, because maybe somebody's in the audience right now thinking, well, I get what you're saying, but at the end of the day, too, I'm have this data, but I'm stuck at how do I even pick a embedding model? What's the process? What are the steps? What's the consideration? Is my data does it depend on the data that I have, or data types and things like that? So maybe you can touch on that a little bit as well.
Yeah. So embedding models are an incredibly important piece of your RAG stack. They're an incredibly important piece of your LLM stack in general. And you're going to need different embedding models depending on the type of data you're working with. So for example, if you have image data, you're not going to want to use a sentence transformers model to
Yeah.
embed image data. You're going to want to use ResNet 50 or something like that, or you're going to want to use Clip, something like that. And if you have text data, you're probably going to want to use some sort of text model. And if you have like video data, you're going to want to use a video model. And if you
Yeah.
have code, if your text is code, you're probably going to want a model that's focused on code and not, just text.
Yeah.
As you specialize down deeper into more niches, you're going to probably need more specialized embedding models.
Awesome. Awesome. Yeah. Yeah. It's very, especially now with like multimodal in AI. I know the way things change so fast. It's always important to be considerate of those things. I think one of the resources you mentioned was kind of going on the leaderboard sometimes and looking at what models are kind of trending. I think there's the one Hugging Face, MTEB. There's so many of them now, but
Yeah.
that's one place to look at. And maybe you're looking. Usually for you, when you go on maybe MTEB, what are you looking for specifically? Does it like maybe just walk us through like just a simple process of maybe an example?
Sure. So MTB has a bunch of different like rankings, and then some of them are in different languages and for different purposes and things like that. And so what you want to basically go do is you want to say, okay, what's my purpose? Am I just looking at a general purpose model? Okay, let's say I'm looking at a general purpose model, and then you want to say like, what language am I working in? Is it English? Is it Polish? Is it Chinese? Is it some
Yeah,
other different language? Like you go and you pick your language and you pick your purpose, and then you just look and you say, okay, here are the top 3, top 5, top 10 models. Let's just check them out, see how they work. Because just because they do well on the MTB leaderboard doesn't mean they're going to do well for your use case, right? Because
yeah,
everything that you should do, the way you pick your technology stack is really highly dependent on how you're going to use it. And it's not like and I guess this is kind of a controversial opinion. There's really no such thing as a general use case model, right? I mean, like OpenAI says, like, oh, this is a general use case model, but like, there's no such thing as a general use case. Nobody is a general use case. Everybody
yeah.
uses things in a specific way.
Absolutely, absolutely. I think you're right on that. There's always a specific model for a specific thing to purpose for it. That's why we have a mixture of experts, right? Uh,
Right.
yeah,
Yeah. Which then they're basically like, here's how we're going to generalize. We're going to have these specific models that do different things, and we're going to generalize it for you by using specific models for different things.
absolutely, absolutely. Yeah. So kind of shifting gears to trying to get your opinion here. So I know there's a lot of moving pieces within the AI space, and so I want to get your opinion on what are you seeing right now as kind of like the direction where things are heading with RAG or new developments that you're seeing in that space, and also maybe you also get your opinion on what do you see as the future of RAG.
Yeah. So I'm actually giving a presentation about this in October at DevSlam in Dubai.
Oh, cool.
There are 3 ways that I see this kind of LLM app stack moving. So number one is multimodal RAG. In let's say 5 years, maybe as close as 3 years.
Yeah.
If you're just doing text RAG, and unless you have a very, very good reason for doing text RAG, you're going to be very far behind. And then the other one is multilingual. So, like I showed you, this one does French and English.
Yeah.
Well, those aren't the only 2 languages. There's German, there's Hungarian, there's Chinese, there's Korean, there's Polish, there's all these different languages.
Yeah.
And, these different languages are also going to have use cases for AI. And so you're going to need multilingual RAG. And then there's also this rise of AI agents. And AI agents right now, I actually created the AI agent subreddit last year, kind of in preparation for this. I
Yeah.
think I was a little bit early. We've got about like 1,000 members or so, maybe like
Yeah.
something like that. But there's really nothing really going on in this space yet. And the reason for this is just because like we don't have the knowledge to really create a lot of things around this yet. And LLMs don't have really strong enough reasoning to really be doing the AI agent work um, yet. But it
Yeah.
will come. And I believe it'll be here in the next 2 to 3 years. And so AI agents are just, the LLMs, tools, whatever, AI, whatever, they can use other tooling. And I actually just released a tutorial recently on how you can use an AI agent to do RAG using Llama Index and Milvus.
Pretty cool. Yeah. Um, I've actually been really interested in AI agents recently. I've been playing around with some of the ones that are out there, AutoGen, Crew AI, and it's very interesting to see how this space is moving. And I also see it as I agree with you. I see it as kind of like the next like a section where this movement is going. And I think it's very interesting to see how you're incorporating AI agents into RAG, which is very interesting to see that. I definitely want to check that out. Um, kind of wrapping up here as well, kind of looking at your experiences that you've had so far, and what do you find as the most exciting aspect of working in the AI space?
The most exciting thing for me in AI is that I've kind of so I got into AI basically because I used to play a lot of like video games, and I was like, oh man, like how do these like how do your opponents, your AI opponents, like how do these things work,
Yeah,
uh, and I don't know if that was like AI or whatever, but like that was kind of how I got into it, and now it's like interesting to see like these advancements in ways that you can interact with it, and like how AI is kind of coming to everyone, right? Like
yeah,
ChatGPT basically made it possible for almost anybody to interact with AI. And this kind of stuff, and seeing the wide proliferation of AI is very exciting for me because this is a space that I've been in, basically, since I started being able to understand these kinds of things.
yeah.
I've been into this space. I've been curious about it, and I guess one of the things that may or may not happen in my lifetime, but would be really cool to see, or it may be also the apocalypse, who knows, is like the singularity of, we're all going to get uploaded into AI. That would be very interesting. Whether or not that's good or bad depends on, your opinion, but I think that would be an interesting technological achievement.
Yeah. By upload, what do you mean? Like get uploaded after life, or even when you're still like alive?
I mean, like, so, like, even if you're alive, like, you can choose to be uploaded into AI, kind of like the Matrix. You can get plugged into this thing. Like, I don't know, like, that would be kind of cool. Uh,
Yeah, yeah,
like,
yeah.
I don't know. There's a lot of philosophical debate around that, but, my physical body has a lot of back pain, and because I'm kind of tall, and like, every person over the height of like 5'10", like, or 5'9", like probably has back pain, and I think it's pretty relatable.
Yeah, absolutely. Then we become AI augmented humans or something of the sort. So
Yes, or human
yeah,
augmented AI.
exactly. Yeah, there you go. Hey, I think we're heading there. It's very definitely. I don't know where we'll be in 5 years, but it's definitely exciting. Would like to see where we're heading. And
Yeah.
so yeah, with that covered, just want to maybe you have some things that you found really like resourceful for you when you're learning about AI or vector databases or anything that we just talked about. If you could share some links, some resources, not even links, just resources that you found really helpful that maybe the community would want to go look into as well.
Yeah. So I would say, follow me on LinkedIn. But but like really, if you want to dig into machine learning, um, my favorite recommendation for this is Elements of Statistical Learning, ESLR. It's a very, very famous base book, and I mean, it's a dense read. Don't get me wrong. Like, unless you enjoy math and statistics, you probably won't enjoy the book. But if you do, then you will enjoy the book, and it will give you a lot of insights into how AI works and why people are like, oh, LLMs hallucinate, blah, blah, blah. Like, there is a reason why. And you can go look into this book and be like, oh, everything is just statistics. So, yeah.
Yeah. Cool. Awesome. Yeah, I think those are really. I've probably not heard about half of this, so I'll definitely go check them out. But I do recommend your LinkedIn for sure. I've watched some really cool videos that you shoot on your balcony or walking around with coffee. Those are always nice to kind of digest those materials. You break it down really nicely. So yeah, definitely, I'd encourage everybody to check you out. And before we close here, Eugen, any final thoughts that you have for our audience before we close?
Sure. So I will just take this time to um, advertise my open source community. So one of the things that I really believe in is open source. I think it's incredibly important, and you're at Streamlit, so I'm sure you understand. Like,
Yeah.
I think it's incredibly important that we take this kind of, let's say, grassroots, ground up approach to AI. I think it's incredibly dangerous to have all of this power kind of concentrated into the hands of a select few, and which is, I mean, I guess that's how society kind of works anyway. But
Yeah.
open source kind of lets people contribute their thoughts, and really contribute to building what the future of AI is. So if you don't like the idea of being uploaded into a machine, you can contribute to that by contributing to open source. And if you like it, you can also contribute to that by contributing to open source. I really think this democratizes the ability to contribute to AI and to be part of the AI ecosystem. And so I've created this community called Open Source Software for AI. And you can find it. Drop the link here. Yep, there it is. You can drop the Luma OSS for AI. This is event calendar. We do workshops, we do tech talks, we do hackathons, and all this kind of stuff. Right now, it's all focused in Seattle, but I'm going to be moving things. We're going to be starting virtual workshops in April, and hopefully more in-person workshops in May. I would love to be able to expand this around the country as well.
Yeah.
And so yeah, that's something that I think people should look into, especially if they want to get deeper into AI. And then other things that are really, of course, Zillis has a great blog, mostly written by me. uh, and who else is? I definitely also recommend like following some like these interesting people on Twitter, right? So like Harrison's on Twitter, Harrison Chase is on Twitter, Jerry Liu is on Twitter. These guys are Length Chain, Llama Index. Check out some of the lesser known frameworks as well. Like Haystack is interesting. Semantic Kernel is interesting. I think Octo AI is doing a great job. I really appreciate how easy they make it to basically just have them as a drop in for OpenAI.
Yeah.
And the models they support are open source. Who else is there's? I mean, there's a ton of players in this space, and they're all very, they're all contributing to this kind of open source ethos. And I think that's the main thing I want to push is for people to get into AI through doing open source and learning about open source and things like that.
Yeah, absolutely. Open source for the win, for sure. Yeah, and with that, thank you so much for joining us today, Eugen. This has been really awesome to have you on. I've had a lot of fun, and I hope the audience had a lot of fun chatting with you. So thank you again.
Yeah, thanks for having me on, Tony.
All right. To your audience, thank you for joining us today for this deep dive into RAG concepts with Eugen Tang. Follow us on social media to catch all our updates and future episodes. And with that, happy streaming and see you around.